space structure ever made by human beings. And we have 6 people aboard the space station at pretty much at any one time. The current crew aboard space station, they're coming down either tonight or tomorrow night. I forget, I think I lost a day when I came over from Houston. The commander of the space station up until a day and a half ago was a good friend of mine, Koichi Wakata from Japan. He was the first Japanese commander of the International Space Station. We rotate commands through the space station, so there's always somebody in charge. And they're mainly in charge for crew safety and helping make sure that the crew works together. And if there's any questions, you know, there's a unified front to the mission controls down on the planet, just to keep everything working great. It's a good system. I was commander of the space station on expedition number 18. Koichi was on my crew for a little bit. There's his name on the patch. And so now he had a chance to be commander, and he and one of my fellow classmates from the astronaut class of 1996, Rick Mastracchio, will be coming down tonight, along with the Russian commander on the Soyuz. They'll land in Kazakhstan. So you heard about the story going up and then coming back is just the opposite, except that you got to go from 17,500 miles an hour down to 0. You don't have any real rocket fuel to do that. You just use the atmosphere to slow you down, no problem, right? Kinetic energy, right? You guys are familiar. You're converting the potential and kinetic energy down to getting rid of it. The atmosphere doesn't like being hit that fast, so it ionizes and glows very beautifully around your spaceship, and the spaceship really heats up. No problem. You have a weighted heat shield, which takes the heat away as it melts away. And the Russians didn't have computational fluid dynamic computers in the 1960s. So when they calculated the heat shield, they said, well, we think we need about this much, so they sprayed on this much. And it's a great engineering decision, because then they didn't have to worry about it. They just doubled what they thought they needed. And sure enough, it comes back and about half of it's gone. But if you're in the capsule sitting down, as you're watching it, it slows down as the spacecraft glows, and you start to see your spacecraft, the blade of heat shield melting, right? It's normal, but as an engineer, it's like, oh yeah, that's the way it's supposed to go. It's all parameters. And on the other hand, the human part is, well, engineers do it too. I didn't even say it that way, but it's like the human part is saying, oh man, my spacecraft's melting around me. I got a window seat, and look, hey, that red one's pretty. That green one, that's like, oh wait, the plasma's only this far from my nose. It was really that far away where all the action was happening. So it was like 4,000 degrees here, and but there was heat shield and the insulated windows. So right here is only what, I don't know, 60, 70, 80 degrees. So it was, it was pretty big temperature differential as we were coming through the atmosphere. So we slowed down. So these guys, it's going to happen the same thing. Koichi's going to have the window seat like I did, and he's going to have a fun ride back. This is Koichi's first ride on the Soyuz, so he's going to have a fun time landing, especially because parachutes come out. Parachutes are good, right? They slow you down. And if you guys saw the movie Apollo 13, right? They all land in the water. And last time I checked, water is a lot softer than the ground. But in Russian rockets, we don't really have a big ocean near Russia, and it gets complicated. So they just land on the ground. It's a lot easier. So they smack on the ground. It's pretty heavy. It's pretty hard. It's like a car wreck in some respects, but it's safe. People come back all the time safely, and that's what's going to happen to our friends tonight. In the meantime, we have 6 people aboard the space station at any time. There's usually 3 Russians and then 3 what they call Americans, but Americans mean anybody from the original Space Station Freedom Project. So Americans always mean at least 1 American, but then maybe a Japanese guy, maybe a European guy, maybe a Canadian guy. When I say guys, I just want to make sure everyone knows that a lot of our astronauts are girls too. So guys, I mean, in the generic sense of human beings. So you can say American human being and Russian human being. And guys are easy, right? So short girls could be astronauts too. In fact, out of my chain of command, so we're not military, but still chain of command. The director of our Johnson Space Center is an astronaut, Ellen Ochoa. She's the first Latina in space. Then the person who's right below her, who's my boss's boss, is Janet Kamandi, who's a material scientist and an astronaut from the Pacific Northwest. And then we have an Air Force guy who's the chief of the office, and then I'm under him. So, so 2 of my 3 main bosses are girls. So it's NASA's a fun place to work with. We take the best of what we get So anyway, so American guys, Russian guys, European guys, and Canadians. So we all rotate through, and it takes now. When I first went for space station flights, it took 4 years for training. Now we're down to about 2 years, maybe even 18 months from the time you get told to be you're going to go on a mission to the time you get to fly. After all that training, we get to get on a Soyuz rocket. That's our only way to go to space right now. We retired the space shuttle, and then we're building new rockets even as we speak. And tomorrow, as soon as I go back to Houston, I'm going to continue working on helping NASA and our industry partners with some new rockets and new capsules, new controls, and all kinds of fun stuff. But in the meantime, so we send people up and down with the Soyuz, and then you spend your time aboard the space station. What do we do aboard the space station? Well, that's a good question, right? You're up there, 6 months at a time, 7 days a week. Can't go out on the mall on the weekends. Can't go home and see your kids. Can't go shopping. Well, nowadays we can't because the new kids these days, they have the internet aboard the space station. My whole year we didn't even have the internet, so I couldn't like buy stuff on Amazon or anything. But delivery would have been a problem, right? You said it was 2-day delivery, and I'm still waiting. So aboard the space station, we do a lot of work, and this work is important. A lot of it's the science. We try to spend at least half the astronaut time aboard working on different scientific experiments, all the way from experiments on human beings, like how does human beings' body change over time in space, the effects of weightlessness on space, how it affects the immune system, things like that, to understanding how things, physical processes work, all the way from flames. Did you know that the flame shape that you see like on a birthday candle is a certain shape because the air is convecting, because hot air rises, cold air sinks. Well, without gravity, it doesn't. So flames in space, if you were to light a birthday candle, would be like a little blue ball over the candle. So all these interesting things that we're learning without the big factor of gravity, we can understand so that we can make life better here on planet Earth. For example, by understanding how flames work in space, we can actually understand the process of combustion a little bit better, and with that understanding, we can actually make combustion, like in car engines or airplane engines, that much more efficient. All of a sudden, cars can get 35 miles to the gallon instead of 32. Well, that's 10% improvement, making life better here on planet Earth. So those are the kinds of things we do aboard the space station. One of my favorite experiments is one that astronauts usually don't need to push any buttons or do anything. But we took up on my last flight, which was the last flight of Space Shuttle Endeavour. And Space Shuttle Endeavour now, by the way, is in Los Angeles. You guys know Los Angeles, right? Not that far away. California Science Center near the University of Southern California. Coliseum is a science museum, and Endeavour is parked there, and it's on display for people to see. So, but on the last flight of Space Shuttle Endeavour, we took up what we call an alpha magnetic spectrometer. I think you guys know what spectrometers are. So basically, we have a Hubble Space Telescope out there in space that looks at the whole universe, but only sees photons, right? And sees light and infrared and a few other wavelengths of light, but it's still all photons. And with the Hubble Space Telescope, in fact, a few people using Hubble Space Telescope data, prove the age of the universe to a very fine degree of 13.8 billion years old, things like that. A few people won the Nobel Prizes for the data that came from the Hubble Space Telescope, but there's still more data to be analyzed. Well, the alpha magnetic spectrometer looks at other things besides photons. It looks at all these charged particles that happen when you slam a galaxy into a black hole. Like you have a fifth grade question, what happens if you took 2 black holes and 4 galaxies and slammed them together? Well, somewhere out there that's happening, and some of those particles are coming so fast, and some of them might be antimatter, some might be matter, and the Hubble Space Telescope wouldn't know any difference because it only looks at photons. Everything else, the alpha magnetic spectrometer is capturing, cataloging, and trying to find out more about the universe around us. And with that, we're going to understand to a better degree what most of the universe is. Here's something that I'm sure your instructors, fine instructors here, have explained to you, but up until a few years ago, we thought we knew most of what the universe was about. We had a fundamental understanding of the standard model of solar system, we can predict where Jupiter is at any moment because we know its initial its speed and direction, and we can figure out the orbital mechanics from there. So then if you look at stars as they rotate around the galaxy, they are not following standard orbits, and they're being perturbed in an incredible way by something we can't see. We call that dark matter. So what the heck's dark matter? Well, it's about 65 to 70% of the universe, and we have no clue. But we have very little clue what it is. Well, the alpha magnetic spectrometer is going to help us figure out the nature of dark matter. And the more we understand the universe around us, and this is where you guys come in, because you guys are so smart, and you guys are trying really hard to understand the universe around us, it's the better we make life here on planet Earth. So one of the videos I love to show, you guys can get on YouTube and see it. It's like, you probably even have, it's on, my friends and I, we make these videos from space. It shows what the planet looks like, especially as you go around on the space station, and what a night pass looks like when we go to the dark side of the planet. You see all these beautiful cities and lights. You know, Italy, it looks like a boot, right? And even at night, it looks like a boot because everywhere there's a city, you can see the street lights, and it outlines the whole peninsula. That's the peninsula of Italy and the whole boot, and it looks so pretty, and it's sparkling like a diamond. So it's like a bling boot at night. You can see it, and it's really pretty. And it's like, okay, if you look down, it's like everyone down there has electricity. And where did electricity come from? Well, it came from you know all the units of electricity, Faraday's, and what are some other ones? Coulombs, and all those. They're named after people. Voltas after Volt. I mean, volts after Volta. All these names, amperes. Those are all people's names because they were looking at this new thing around the universe called electricity. It was kind of a curiosity. Well, then we figured out in the 1800s how to harness electricity, and now it makes life better on planet Earth. We don't have to go to try to just study at night and then with candlelight like Abraham Lincoln and all that anymore, right? We've got electricity. We have our plasma TVs. We can do all these things now with electricity. We have our iPhones. We're good. And it all had to do because we understood a little bit more about our universe. So, who knows, 50 years from now, one of you guys will be living a big, cool life as a billionaire because you figured out how to make dark matter engines and solve the world's energy crisis. Everybody can live large thanks to you. You've got your nice yachts, dark matter engine yachts. Right? It can happen. The more we understand about the universe, the better life will be here on planet Earth. So that's what we do aboard the International Space Station. Again, our cruiser. We have one crew coming down in a few, let's see, next week we're going to have another Soyuz launch with another couple of Russians and Americans aboard the space station to go up to space, including a German astronaut, and the cycle will continue. Myself, I already did that twice. I'm hoping to go again. I'll probably launch on a different rocket than the Russians because I've been there and done that. We're building new rockets here in the United States, working with industry partners such as SpaceX, Sierra Nevada company, Boeing, and Orbital Sciences in Virginia, and we're building new rockets and new ways to get to space. We're also building these rockets cheaper, faster, smarter, and a lot safer. So what that means is that pretty soon, hopefully, we're working towards NASA and industry are working together to help make a new industry such as we did with airplanes. 100 years ago, very few people were ever flying on airplanes. It was a big curiosity. Now, you spend about $1,200 to $1,500 and you go anywhere on the planet within 24 hours. Except maybe Antarctica, you might have to wait an extra couple days. But isn't that pretty cool, amazing? 100 years ago, if you wanted to go anywhere, you would have to get on a boat or something like that. It would be a big hassle. Now you show your passport, pay your ticket, and you can be anywhere you want. Except North Korea, you probably shouldn't go there. All right, so we're hopefully doing the same thing in space flight. So the opportunities in front of everyone here is pretty amazing. If you do get the chance to see Earth from space, get ready for it because it will take your breath away. So that's all I have to say. Let's answer some questions, and if there's so many ice cream left.